Okay, day 2 of still working trig identities. So we're still going to be doing what we've been doing. We're just upping up the level a notch, okay? So let us start here with, actually let's start with part D. Let's do part D because part D is just like day 1 type problems. Go ahead and break that one down and simplify to a single term for me. So part D says tangent of theta times cosecant theta times cosine theta. So go ahead and do that. All right, tangent. Break it up for me. What did you all get? Sine over cosine, good. So sine theta divided by cosine theta. How do you say this? Cosecant, good. What is cosecant going to be? 1 over sine theta. And the cosines we don't touch, right? So what did you guys notice? Very good. So everything canceled out. As long as in multiplication you have a numerator and denominator that match, we can cancel like crazy. So 1 was our final answer. That was what is left over. Okay? Alrighty. So let's go back to A. So here's some new stuff that I want you guys to be aware of. Sometimes you guys are going to get a rational function. Rational means fraction, where you have two terms adding in the denominator and they are both dividing by a common denominator. In this case, they're both dividing by tangent. Okay? So what I want you to do to make it simpler is you guys are going to split this up so that it looks more like a day 1 type problem to help you finalize and simplify it some more. So what I'm going to do is, this line says both of these are being divided by tangent. So I'm going to split it up where I write tangent over tangent. So I'm going to write tangent theta. Don't forget to be writing your thetas all along, okay? Tangent theta over tangent theta. And then I'm going to put a plus because our problem has a plus. And then I'm going to share the tangent also with the other term. So cotangent theta over tangent theta. So all I have done in this problem from here to here, all I did was rewrite the problem. There hasn't been any math necessarily been done to help simplify it just yet. All I did is rewrite it as a sum of 2 fractions versus them being condensed into 1 fraction. Does everybody understand how to split these up into 2 now? Everybody good? Okay. Once you split it into 2, you then can visualize them as 2 separate problems, just like you did in the first section. That's why we split it up, so that you can see them into 2 different problems. What is tangent over tangent? 1. Good. Plus, now we have cotangent theta over tangent theta, which what we did was we broke it up in day 1 type problems, right? Cotangent theta, let's see, Ermela, what is cotangent theta in our chart? So you start practicing. Find cotangent theta. And you can help her, Danica. Good. Very good. Cosine theta over sine theta. Okay, so there she substituted cotangent theta with the formula cosine over sine. Then we put divide by, and we're going to do tangent theta now. Okay, Keaton, what is tangent theta? Sine theta over cosine theta. Now at this point, I want you guys getting accustomed to cotangent and tangent to the point that you don't even have to look at your formula sheet. Remember, cotangent, the first 2 letters in cotangent are CO. So know that cosine goes at the top, then sine at the bottom. Therefore, tangent is always going to be sine over cosine. So always remember that sine over cosine, cosine over sine. It makes it easier. Okay, here's our keep, change, flip scenario. We have a stacked fraction So we are going to rewrite. So we bring the 1 and the plus over. We keep the first fraction, which was cosine theta over sine theta. Change it to multiplication, and we flip to make it cosine over sine. Okay. Now, what you guys are going to find unusual, because in day 1, anytime you guys implemented that keep, change, flip, multiply by the reciprocal, you ended up having something cancel, all right? And it just so happens in this scenario, it doesn't. So just know, every once in a while, things don't cancel, but they still will work in the long run. Here, our cosines are both in the numerator, sines are both in the denominator, so you cannot cancel, right? So we will just go ahead and combine and simplify. So I'm going to bring the 1 plus, what is cosine times cosine? Cosine squared. So cosine squared theta and sine times sine?
Sine squared theta.
Good. So now, 1 plus cosine squared theta over sine squared theta. How can I rewrite that? Come on, y'all should be saying that already. Anytime, listen, you guys, I think you guys think that these formulas are like all crazy and stuff. I want you to notice that here's your formula chart. These right here are all 1/overs, right? All those are 1/overs. You only have 2 that are fractions with 2 trig function. It's either sine over cosine or cosine over sine. It's cotangent squared. So it's a 50-50. So when you guys see sine over cosine or cosine over sine, y'all are overthinking it. It's either going to be sine or cotangent or tangent. So don't make this chart hard, okay? The majority are 1s. You guys are just using these like the majority of the time, okay? So that's cotangent squared. Now, as soon as you see 1 plus, 1 minus, and all that kind of stuff, you know that you need to go down here and look at stuff over here. Okay? So 1 plus cotangent squared. Let me know when you see 1 plus cotangent squared. Cosecant squared. Very good. Cosecant squared is at the bottom left-hand corner of your chart. Okay? Cosecant squared is at the bottom left-hand corner of your chart. So, what I want you to do now is I want you to follow suit with what you just finished doing in part A. I want you to do part C, okay? I want you to go and do part C right now on your own. You may collaborate with your peers if you would like. All right, so we're going to go ahead and I'm going to go ahead and split this up. And then you guys tell me, how did your split fractions, summation of fractions end up being? All right, so if you're following suit like you did in part A, this is what you would have done on your first step. All right, what is secant squared theta over secant squared theta? It's a 1 plus, what is 1 over secant squared theta? Okay, but what are you missing in that? Very good, cosine squared. So 1 over secant is cosine, so 1 over secant squared theta is going to be cosine squared. Uh-huh. You did. Oh, thank you. I made a mistake and you caught it. Excellent. Excellent. Thank you for that. Alrighty. And then 1 minus cosine squared theta. Do you have that already, Ermela, by any chance? Sine squared theta is correct. Okay. Good job. Are there any questions on that? All right, so what I wanted to show you guys, and actually, Ellie, if you don't mind me using your paper, can I use yours? I wanted to tell you guys how there are different ways you guys can do this, and I purposely had you guys do this way because I wanted you to practice the process of A. But Allie was working ahead and she ended up doing it another way, and I wanted to show you how, as I told you guys in day one, you may do one method and somebody else may do another method algebraically, but you'll end up with the same answer. So look at the way she did this one compared to this one, and she ended up with sine squared. So she recognized that secant squared theta minus 1 in her chart is tan squared. Okay? And then she rewrote her secant squared theta as 1 over cosine squared. And then she rewrote tan squared as sine squared over cosine squared. And then multiplied by the reciprocal because she had a stacked fraction. Those canceled, so she ended up with a sine squared. So know that there are different methods and approaches to take. Okay? And thank you so much for lending me your sample. Okay? All right. If there aren't any questions, we will proceed to part B. So part B is definitely something very different to anything you've seen. So let us show you how to do this one. All right. So one thing you'll notice is that you have a cosine squared, and usually what we say, okay, it's a cosine, we don't change it. And then we see a 1 minus sign, and we go to our chart and we notice, well, we have a 1 minus sine squared, but not a 1 minus sine. And so you might start thinking, okay, maybe this is a typo, but actually it is not a typo. It is 1 minus sine. So one thing I want to caution you against, sometimes students do is they say, if 1 minus sine squared is cosine squared, they like to make the deduction that cosine theta then is the same thing as 1 minus sine theta. And that is not a true statement, okay? What you do up here with the squares, you cannot do with down here with the squares. And what I mean is, when you guys say, for instance, cosecant theta is 1 over sine, and so you say, oh, well then cosecant squared theta is 1 over sine squared theta, you can do that with all of these upstairs. You're allowed to do that all day. But with these down here, you cannot use the same deduction because it's over addition and subtraction. You can only do this over division and multiplication. So your question may be, all right, well then how exactly do we do these problems? So here's what I want you to see. You are going to leave that 1 minus sine theta, and I want you to rewrite cosine squared theta. Now you have two options. You can rewrite cosine squared theta as 1 over secant squared theta, or you can use this cosine squared theta, which is 1 minus sine squared theta. Since your denominator has 1 minus sine, the probability says that we should be using this one more. So let's replace our cosine squared theta, which is this, with 1 minus sine squared theta. Okay? So let's come over here. I'm going to put an equal sign. Cosine squared is equal to 1 minus sine squared theta. And then that denominator, I just want you to bring it along. Okay. Now, right now you probably may still be like, yeah, I don't understand yet why do it this way, but in a second you'll understand why this method works, okay? All right, so taking a trip back to Algebra 1 and Algebra 2, we had a type of factoring called difference of squares. So let me remind you, if you have forgotten, what factoring by difference of squares mean. The formula for factoring by difference of squares says, if you have two numbers that are subtracting, that's what difference means. If you have two numbers that are subtracting that are perfect squares, you can rewrite it as a minus b times a plus b, or a plus b times a minus b. Now, if you're saying, okay, yeah, formulas, I don't get those, I see it, but I do not understand how that works. Okay, so we're going to use an example to help you clarify what this means. So here's an example of factoring by difference of squares way back in Algebra 1 and Algebra 2. And you'll be practicing more factoring in second semester of pre-calc. So x squared minus 100. Let's use this as an example. Let's do a non-trig problem. This is a perfect square, and these are both perfect squares. So the way you factor is you have a set of parentheses, okay? And what you do with difference of squares is that you square root. The opposite of squaring is square rooting. What is the square root of x squared? What is the square root of x squared? What's that? It is x. So, whatever your answer is, put it in the first slot of both factors. Then, see how these have to match? They are matching. Then you put a minus and a plus, a minus and a plus, or if you prefer putting plus first, put a plus and a minus. And then to get your b, you needed to square root your b squared. So what is the square root of 100? 10 is correct. So I put a 10 and a 10. And you are done. X minus 10 times x plus 10 is the same thing as x squared minus 100. This right here is a difference of squares. I need you to factor your numerator just like you just did upstairs with x squared minus 100. So let's do that together. I'm going to put my division line, and I'm going to put parentheses, and we're going to do the same questioning technique. This is my a squared, and this is my b squared. What is the square root of 1? 1. So I put a 1 and a 1. Then I put a minus and a plus, or a plus and a minus, whatever you prefer. And then you square root the other one. What is the square root of sine squared? Very good, sine. So I'm going to put sine theta and sine theta. And then I'm just going to bring down what my denominator was. So hopefully you start seeing the purpose of factoring. Why did I need y'all to factor? What's going to happen now? Very good. We're going to see some canceling happening. So now I can cancel out those factors that are repeated, and I have simplified my expression down to 1 plus sine theta. Okay. So look out for difference of squares. So here's what I want you to realize, the power of your factoring. Okay, in your chart up here, all of these, if you are an avid note taker, and I mean it in both senses of the word, avid is if you're an avid, and also avid as you are very diligent in taking notes. All of those right there, or actually, why did I only circle? Yeah, no, these two. All of these right here can be rewritten in difference of squares format. Every single one of these are subtracting, 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 and subtracting. So if I wanted to rewrite this piece in factored form, I would write it as 1 minus secant theta times 1 plus secant theta. If I wanted to write this one in factored form, it would be 1 minus cosecant theta, 1 plus cosecant theta, and so forth. Every single one of those can be rewritten in factored form because they are all differences of squares. Does that make sense? So keep that trick in mind. Okay? Keep that trick in mind. Okay. Moving a little down to verify an identity. So, verification is going to be the primary goal of a lot of your homework problems. And what I want you to do is cross out all of this that I'm crossing out on my page to simplify the directions. I only want you to work on a side separate from the others. And I'm going to have you ignore what we call the simpler looking side, okay? You're going to ignore one of the sides of your equation, and you are going to work separately with the other side, okay? Now, if you don't understand what that means, I'm going to show you through the example number 1, okay? So cross out what I crossed out there. We're going to work on one side separately from the side that you ignore. So in example 1, we have an equation with a left side and a right side of an equation. It's an equal sign. Which one of those two sides, left or right, is the simpler looking side? The right side. So ignoring means strike through it and pretend that you don't have that side, okay? Now what you were ignoring is actually your answer key, for lack of better words, okay? So what your goal is you're going to work on the left-hand side, break it down, and your answer must equate what you just finished ignoring. So it's as if the answer was in the back of the book and you had this as a problem and you're like, oh, okay, my answer is 1. I need to work it out and make sure I end up with a 1. That's what verification means. So sine doesn't change. Cotangent, what does cotangent change to? Cosine over sine. And secant changes to what? 1 over cosine theta. Thank you. And so we do what we recognize. Cancels. And we notice that we're left with a 1, which is what we crossed out, right? As soon as you end up with what you crossed out, stop, put a check mark, and that tells me you verified. You're done. Okay? So it's the same thing what we've always been doing, except I give you the answer because I'm giving it to you in equation form. Okay? Sometimes you'll end up with problems like example number 2. That is kind of hard to see. Well, there isn't really a simpler looking side between the left and the right. So when you end up with a situation like this, just pick a side. It doesn't matter. What side do y'all want to ignore, left or right? Right? All right. So we're going to cross out the right. Okay. If you were one that said, oh, I wanted to cross out left, cross it out, and you'll see that you still get the same answers, the same type of work. Okay, so our goal is to get this as a final answer. Our final answer has to be 2 cosine squared theta minus 1. Now, 1 minus 2 sine squared, is that anywhere in our chart? It's not, right? See several people shaking their heads. You're correct. It's nowhere to be seen. So when you end up with a situation like that, you're like, okay, I don't have this whole thing, but I definitely have sine squared. Okay? So, of your sine squared formulas, what is the formula you're going to use? Are you going to use sine equals 1 over cosecant theta? Or are you going to use sine squared equals 1 minus cosine squared theta? And before you answer, look at the answer that you're trying to get to help you decide. So would I use 1 over cosecant squared theta, or am I going to use 1 minus cosine squared theta? Very good. My final answer has nothing with secant in it. So why am I going to use it? Don't use it. So let's substitute. So I'm going to bring down my 1 minus 2 times 1 minus cosine squared theta. So I'm substituting sine squared with 1 minus cosine squared theta. What do y'all think we need to do next? Keep looking at what we need to get. It looks close enough, but we're not just there yet. So what do I need to do? What's the difference between this and this right now?
It's a negative 270 over 1.
It's a -2 instead of a -1. What else? Very good. The 1's in the wrong spot. And what's that? What else? There's something else. Parentheses. Good. So what do we need to do? How do you get rid of parentheses? Distribute. Very good. Multiply. Very good. So what am I multiplying what's inside the parentheses by? By -2. Very good. So I'm going to bring down the 1, and I'm going to distribute -2 to this and to this. So -2 times 1 gives me a -2. -2 times negative cosine squared gives me a? Very good. So notice when they multiply and they're distinct, just stick them together, right? All right, so we got rid of those parentheses. It's definitely looking a lot better. We're close enough, but not quite there yet. What needs to be done? Go ahead, Stacy. Very good. Combine those like terms, and what do you get when you do 1 minus 2? -1, right? That's going to be a -1. So they want our answer to be written like this, so we'll write the 2 cosine squared first, and then Stacy's combined like terms, -1, and we say stop. We got to where we crossed out stuff. Okay. So verification is just like what we've been doing, except I'm providing you with the answer key. Okay. And sometimes students will start with one side and they can't work it out, and they'll erase and just ignore the other side, and sometimes the other side is easier. So know that that can be done sometimes. Okay. Alrighty, let's flip over. Going there, going there. We should probably be able to finish before lunch. Okay. Okay, here's one other verification. So I'm going to cross out the one because it's obviously pretty obvious. That's the simpler looking side. So I'm going to bring this down here and write it a little bit bigger because it's so small up there. Okay, so here is another example of factoring that I'm going to remind you guys of. Okay, so factoring by greatest common factor. And the best way to teach factoring by greatest common factor, just like the previous one, is giving you guys an example. So I'm going to do an example with you to kind of remind you. Because when you don't use something, you tend to forget, okay? Gets cobwebs on it. Okay, so if I give y'all an example such as this, such as, in Algebra 1 and Algebra 2, if you got something like 8m to the 3rd power plus 2m to the 5th power. Let's do that. Yeah, 8m cubed plus 2m5. If I asked you to factor that expression over there on the right by using greatest common factor, here's what you would do. So I'm going to ask you the questions to help lead you if you have forgotten how to do this. You look at your coefficients, 8 and 2, and you ask yourself, what is the highest number that's divisible by these both numbers? Very good. The highest number that can be divided by both of these is 2. So her coefficient, the highest number is a 2. Okay. Then you look at your variables, m cubed and m5, which just means m times m times m, and m multiplied 5 times. What do these two have in common? How many m's do they have in common? 3, right? This has 3. Does this have 3 at least? Yes. So the highest number they have in common is a 3. So 2m cubed. So you always write your GCF first. This right here is your GCF. Okay, that's your greatest common factor. And then inside the parentheses, you will write out what was left when you undistributed. Okay? Factoring is all about undistribution. So if I took 8m cubed and I divided out 2m cubed, what was left over? In other words, 2m cubed times what gives me 8m cubed? 4. Good. Okay. Then I'm going to put my plus. 2m cubed times what would give me 2m5? M squared. So here you factored your expression. You guys are going to do the same thing with your trig. Okay? So what you learned back in your 9th and 11th grade years, you're using here in your 12th, or your 8th and 10th, and you're using here in 11th, depending on your track. Okay? So, same questioning technique that you used here, I'm going to use over here. What is the greatest common factor in these two expressions? What do they have in common? What is the greatest thing they have in common for both? What does common mean, by the way? Same. Very good. So, what do they have what do they have greatest same? Almost. But you have to remember you're in trig, so you're giving me trig terms. What common trig terms do they have? Which one? Do they have
Cosecant.
Cosecant is the same. Here's your minus sign. On this side you have a cosecant squared, and on this side you have a cosecant squared. That's what they have the same. Okay, I'm going to highlight it here. On this side you have a cosecant squared. On this side you have a cosecant squared. Okay? So my greatest common factor is a cosecant squared theta. Open parentheses. Okay? Cosecant squared times what will give me a cosecant squared?
1.
A 1. Then I put a minus. Cosecant squared times what will give me cosine squared theta cosecant squared? There you go. And you're done. So if I do this times this, I get this. If I do this times this, I get this. See, if I did this and this, I would end up right back where I started. Okay? You are undistributing is what you're doing. Okay? You're undistributing. Alrighty. So far, are we kind of okay? How do I break this down? Remember, our goal is a 1. That means everything's going to cancel out. That's what that means. How do I write cosecant squared? You can do it. What is cosecant squared in our table going to be? So you have two answers. You guys can use cosecant squared as 1 plus cotangent squared, or cosecant is 1 over sine. Which one are y'all going to use? The top or the bottom? What do y'all think? You're trying to get to a number 1. Which one of these is going to be the better one to use? You're going to use the bottom, so you're going to put 1 plus cotangent squared. Do y'all have... You guys want to use this one. You guys are trying to cancel. If your answer is a 1, you guys, that means everything's going to cancel. Okay? So that one downstairs is going to make it more complicated. right? 1 over sine squared. Okay. What is 1 minus cosine squared? Good. 1 minus cosine squared is sine squared. Okay. What do y'all notice happens? What is your answer? 1. Okay. That makes sense? Okay. All right, so I'm going to stop and finish. The last 3 problems are going to take us maybe 5 to 8 more minutes, but we'll do that after lunch because y'all's brains are fried. Told you it'd be a little bit long, but you're doing well, okay? So, okay, so here we go with part A of example 5. So the last couple, these are not verification, these are just us simplifying and whatnot. And so as you guys had said earlier, parentheses imply multiplication. So on this one, you guys are going to do distribution, which in some manners, when you have a binomial times a binomial, some students like to refer to the acronym FOIL, where you multiply the first, outer, inner, last. So let's multiply together, okay? Let's multiply sine times sine, and what would you get there? Sine squared. So when you start multiplying, you'll notice that your parentheses disappear. That's the whole intent of getting distribution. And then we multiply sine times cosine because you're multiplying the outer terms. And when you multiply 2 distinct terms, you just put them side by side. So since they were both positive, we'll put plus sine theta, cosine theta. So just put them to sit next to one another. So that's the first, the outer. Then you multiply the inner terms. So negative cosine theta times positive sine theta will give you negative cosine theta sine theta. And I had students ask me, can I just switch the order so that it matches this one? So like if you want to write it like this, sine theta, cosine theta, you totally can, okay? And the reason you can is multiplication is what is it? I think it's commutative. 2 times 3, 3 times 2 both mean 6. So order does not matter as far as that operation goes. And then we multiply the last terms. Cosine times cosine, so you get negative cosine squared theta. Okay. Let me write this better as singular. Okay. So notice that your 2 middle terms in this scenario are going to end up being 0. Okay, they're going to 0 out because a positive sine theta cosine theta and a negative sine theta cosine theta makes a 0, like negative 2 plus 2 or negative 3 plus 3. So those cancel out and you're left with sine squared theta comes down and your minus cosine squared theta comes down. Okay. Alright, so up to here, are we okay? No problems? Okay. So in the instructions here for part A, they're telling us that there are 2 different ways you're going to leave this answer. For our notes, which is what we're doing right now, I want us to leave it in terms of sine squared. Okay, I want to leave them in terms of sine squared. And they're giving you that in the heads up that in the homework set, you guys are going to leave it in terms of cosine squared. So what that means is this final answer is not completely final just yet because they want you to only have sine squared as your final answer. So how do I rewrite cosine squared to make it disappear and I only have sine as my term? So what in our chart, in our formulas, can I replace cosine squared with so that it's only in terms of sine? Very good. So I'm going to bring the sine squared over. I'm going to put a minus and I'm substituting cosine squared with 1 minus sine squared. So now I'm doing exactly what the instruction says and making sure everything is written in terms of sine. So I need to get rid of those parentheses one more time. So again, you guys are going to distribute this negative, and you get sine squared theta, a minus 1, and a plus sine squared theta. Okay, so I distribute negative times 1 is a negative 1. Negative times negative sine squared is a positive sine squared. And then I know that I can combine like terms. What's sine squared plus sine squared? Very good. 2 sine squareds, because there are 2 of them. And there is your final answer. Just like they said, in terms of sine squared. So there are no other trig terms in your final answer. Okay. Okay. Last 2. For part B, whenever you see a squared term, that just means that you are going to multiply. So I want you to distribute this one on your own. So I'm just reminding you that squared means write twice, okay? You need to write it out twice in order to multiply. So when you practice what you just learned in A and multiply, but that's all I want you to do. You don't need to write it in terms of sine and cosine, none of that stuff. Just straight up multiply. So I'm going to give you a second to distribute and combine like terms. Alrighty, here we go. Tangent theta times tangent theta. Tangent squared. Tangent theta times 1. Alright. 1 times tangent theta. And 1 times 1? 1. Okay. So these 2 terms, what do they become? Yep. A tan theta plus another tan theta, that makes 2 tan thetas. And you are done. Okay. So FOIL distribution, notice it's similar to when you guys are multiplying with variables. Okay, nothing changes as far as your approach. Okay. And here's our very last problem. And you survived day 2 of trig identities. Here is another type of factoring that looks just like difference of squares. If you have what's called, this is called a perfect square trinomial. Okay. Just like difference of squares with square rooting, you do the same thing with this one. Okay. You do the same thing like you did in part B of the front of our notes. So here's what you do. You still are going to have 2 sets of parentheses, okay? You are still going to square root the first and the last term. So if you square root sine squared, what do you get? What is the square root of sine squared? Sine. Good. So I'm going to write sine theta on this first spot and sine theta in this spot. And then you also square root the last term. Skip the middle one on this one. What's the square root of 1? 1. So I'm going to put a 1 right here and a 1 right here. Okay? So notice, just like difference of squares, you're just square rooting the end terms. Okay? Now, with difference of squares, it's always a plus and a minus. It's always plus and minus. When you have a perfect square trinomial, you have to decide, is it 2 pluses, 2 minuses, or a plus and a minus? That's where you have to decide here, okay? So, looking at your signs, what I always tell students is to look at the last one. if your last number has to be a positive 1, that means these two numbers here have to multiply to give you a positive 1. So between this, and this, which one of these can you eliminate to be a possible answer, to get positives? Is positive times positive give me a positive? Yes. Does negative times negative give me a positive? Does positive times negative give me a positive? Okay, so that's definitely not a possibility, right? So I'm going to take that off the possibility. Now we have to decide, is it plus plus or minus minus? How do you decide that one? What's it going to be? Is it going to be plus plus? You use the middle one, yes. You use the middle one to help you decide. So is it going to be minus minus or plus plus if you look at your middle term? It has to be minus minus. Your middle term is a negative, so your answers have to be minus minus. Now, if you're looking at this, you're like, I don't know, I can't see how this is that. Well, you would have to FOIL or distribute to be able to see it. If you want to check it because you're not sure, sine times sine is sine squared theta. Sine theta times minus 1 is a negative sine theta. Negative 1 times sine theta is a negative sine theta. A negative 1 times a negative 1 is a positive 1. And these two combine to be negative 2 sine theta. And there you go. You can see that it is the original problem that you had up here. Okay? But instead of having to do all that work, if you just use the square rooting, and then you use that sign process of elimination with what Ali said here, with the last term being the middle term, determining, clutching in what the final answer or choice would be. Okay? So that's it, my friends. That's it. So the next 2 pages, as you see, the first 4, I gave you these answers. You are coming up with the answers, but then over here it's just verification, so you would just cross out the simpler side, work it out, and try to end up with the answer you crossed out at. Okay, so let me know if you have any questions. You guys did very, very well. Okay, the rest of the time is yours.